In this lesson, we're going to look at quadratics in factored form, and we've actually seen factored form before. So let's review that. We've seen equations that may have looked like this: x plus 2 in brackets and then x plus 3 in brackets. And you might have been asked to expand this using the distributive property and then simplify. And when you did that, you had to use FOIL. So you had to multiply the first, the outside, the inside, and the last terms together. So let's go ahead and do that. Our first two terms multiplied together, you would get x squared. Our outside terms multiplied together is 3x. Our inside terms multiplied together is 2x. And our last terms multiplied together is 6. And when we simplify this, we can combine the two terms in the middle. So this is just x squared plus 5x plus 6. So we've already learned that that's a quadratic, but in standard form. And we got that by expanding. But we can go from expanded form or standard form like this to factored form. So here's our equation: y equals x squared plus 5x plus 6. We've already learned that we can factor this. So do you remember how to factor this using product and sum? You want to find two numbers that multiply to give us 6, but when we add those same two numbers, it gives us 5. And that's just 2 and 3. 2 times 3 equals 6, and 2 plus 3 equals 5. So when we use those two numbers, we would put them in brackets like this: x plus 2, and then x plus 3. So that equation is now factored. And we know that these two equations are equivalent. And let's also review how to solve a quadratic equation. So when a quadratic equation is in factored form, we can solve it. If y is equal to 0, we can plug that into this equation. So when y is equal to 0, we're going to get x plus 2 times x plus 3. And we can solve this quadratic equation by separating its factors. So we need to solve 0 is equal to x plus 2, and 0 is equal to x plus 3. Because we know that when either bracket is equal to 0, the whole entire equation is going to be equal to 0. So in our first case, x is just equal to -2, and then in our second case, x is just equal to -3. So that just gave us the solutions for x when y is equal to 0. And that is going to help us to graph the quadratic. So you've already learned how to graph a quadratic that's in standard form, but let's learn how to graph a quadratic that's in factored form. So here's our quadratic equation in factored form, and factored form gives us particular information. The value of a in front tells us if the parabola is opening up or down, so it tells us the direction of opening. The values inside the brackets, p and q, and I'm going to highlight them. This tells us what the x-intercepts are. And x-intercepts are just the points where your graph is going to cross your x-axis. So let's just quickly draw an example. If we want to graph the equation y is equal to x plus 2 times x minus 4, it might look something like this, and I will draw a rough sketch. So for this example, these are my two x-intercepts. This is where the graph crosses the x-axis. And this is when x is -2, that's the opposite sign that we have in our equation, and also when x is +4. And again, this is the opposite sign of what we have in the equation. So in factored form, this directly gives us our x-intercepts, and it's always the opposite sign of what we have in the equation. If you forget that, you can always solve your equation, because what is the value of y at our x-intercepts? All of our x-intercepts are on the x-axis, and we know that the value of y on the x-axis is just 0. So when you plug in 0 and solve your quadratic equation in factored form, you can easily find your two x-intercepts. So let's work on sketching a parabola in factored form and do it a little bit more accurately. In our first example, we have our equation in factored form, y equals 3 times x minus 2 times x minus 4. And we can use this equation to identify our x-intercepts. So we're going to use the opposite sign since it's x minus 2. Our first x-intercept is a positive 2. And the second x-intercept is going to be a positive 4. So let's just quickly graph that. We have an x-intercept at 2 and another x-intercept at 4. And since this is a quadratic equation, we know that this graph is going to be in the shape of a parabola. And parabolas are symmetrical. So the line of symmetry is going to be directly in the middle of these two x-intercepts. And we can see from the graph that right in the middle between 2 and 4 is 3. So our axis of symmetry is 3. And we can also find this algebraically. We need to find the two numbers that are directly in the middle of the two x-intercepts. And we do that by using the average, or finding the average between our two x-intercepts. So we need to take our two x-intercepts, 2 and 4, and we're going to add them together and then divide them by 2. This will give us the exact number right in the middle. So 2 plus 4 is just 6, and when we divide 6 by 2, that's just 3. So this is what our axis of symmetry is. X is equal to 3, and that's exactly what we found on our graph. And let's put that back up here. And now let's find another point on the graph. We can use our axis of symmetry to find the vertex of our parabola. Remember, the x value in the vertex share the same x value of our axis of symmetry. So if we just plug in this value for x into our quadratic, then we can find our y value. So our equation is y equals 3 times x minus 2 times x minus 4. And if we just plug in that value of x from our axis of symmetry, we'll get our y value. So we're just plugging in 3 into this whole equation. So this is just y is equal to 3 times 1 times negative 1. And that is just negative 3. So that means our vertex is the point 3 and negative 3. And that's another point that's on the graph. And we can plot that point here in our graph. So that point is right over here. So we can roughly draw the sketch of our parabola using those 3 points. And looking at this, we can see that our parabola does open upwards. And now you should be able to try the next one on your own. So pause the video and come back when you're ready to check the answer. So here's the solution. We have our two x-intercepts on the x-axis at negative 5 and 8. I'm just going to write the coordinates here. So this is at negative 5 and 0, and then at 8 and 0. To get the axis of symmetry, I added negative 5 and 8, the two x-intercepts, then divided by 2, and I got 1.5. So the equation of the axis of symmetry is at x is equal to 1.5. So that's this orange line right here. I used the axis of symmetry 1.5 and plugged it into our equation to find the y value of our vertex, and I got 8.45. So the vertex, which is another point on the parabola, is 1.5 and 8.45. And you can see from drawing the graph that this parabola opens downwards. But you can also see by looking at the equation that we have, the value out front of the value of a is negative, so that means it would open downwards. In this next part, we're given the graph of a parabola, and we need to use this graph to find the equation in factored form. So remember, the equation of a parabola in factored form looks like this. So we have our equation in factored form. Y equals a times x minus p times x minus q. And remember, the value of p and the value of q are just our x-intercepts. So if we have a graph, we can identify our x-intercepts, and that's at -2 and 4. So let's just go ahead and put that into our equation. And this x minus -2, that's really just x plus 2. So I'm going to rewrite that. So looking at our equation, y equals a times x plus 2 times x minus 4. And remember from our equation that the sign in front of p and q is opposite of our x-intercepts. So here we have x plus 2, and we have an x-intercept at -2. And here we have x minus 4, but we have an x-intercept at a +4. Now that we have this equation set up, it looks like we're almost done, but we're not just yet, because we have a here. There's going to be a value for a, and we need to find out what a is equal to. To find what a is equal to, we can use another point that we see on this graph, plug it into our equation for x and y, and then we want to solve for the value of a. So let's look for another point. You have some options here. You can choose the vertex, which is a point. You can also choose the y-intercept, and across the y-intercept is this other point. So I'm just going to choose this y-intercept, and the coordinates of the y-intercept is 0, 8. So you need the coordinates of your point. So when you plug that point into the equation, we need to plug in 8 for y. A is going to stay the same because that's what we're solving for. And then for x, we're going to plug in 0. And now we just need to solve this equation for a, so we need to isolate a. So we're going to keep 8 there. We can do the calculation in the bracket, so 0 plus 2 is just 2, and 0 minus 4 is just a -4. 2 times -4 is just -8. And we need to divide by -8 to get a on its own. So a is just equal to -1. And now that we have found a value for a, we can plug that back into our equation that has our x-intercepts. So y is equal to -1 times x plus 2 times x minus 4. And there you have it. Here is our equation of this quadratic relation in factored form. And now you should be ready to try this next question on your own. Pause the video and come back when you're ready to check your answer. So here's the start of my solution. The x-intercepts are -7 and -3. That's where the graph, the parabola, crosses that x-axis. So I inputted those values into our equation, and I got y equals a times x plus 7 times x plus 3. Then you need to find another point that's on that parabola, and the only clear point on the parabola was the vertex. So this is the coordinate -5 and -6. -5 is the x, and -6 is the y value. So you need to plug in the coordinates into your equation for x and y. Don't mix this up. X goes in the brackets, y is on the other side. And then you need to solve for a. So once you solve for a, you should have gotten that a is equal to 1.5. And now we can actually create our final equation of this parabola. So y is equal to 1.5 times x plus 7 times x plus 3. And that is our equation of this parabola in factored form.